Hey guys, welcome back to part 5 of the Tic Tac build. Now, in this part, as you can see, we're going to be working on the build plate assembly. So basically the final mechanical assembly. Now, before we get started, I just want to give a shout out to ratrig, because if it wasn't for the ratrig V-Minion, Squirrel Brain wouldn't be able to come up with basically a little smaller version of that V-Minion. So shout out to ratrig as well. They also make awesome printers. I like their Vico 3. That I mean, also the ratrig V-Minion. Um, I would have built a V-Minion myself, but I don't have a lot of spare 3030 extrusion. Those are kind of a thicker extrusions, and so I didn't want to go on my way and purchase all that fun stuff. Especially given all the enormous 2040 and 2020 extrusion I have. So I'd rather make use of that. So that's when I saw this build, when I saw this design, I had to reach out to Squirrel Brain and tell him like this is an awesome design and I love it. So that's why I'm building this and kind of showcasing this. So if you want to look at it, like I said, this is just a miniaturized V-Minion, just slightly smaller. This is a 120 by 120 versus 180 by 180. So, but yeah, I just want to shout out to ratrig, shout out to Squirrel Brain. Like again, super awesome, super happy with the way this is turning out, guys. Again, super rigid little printer, man. Like I'm still impressed by the thing, man. Just looking at it. So, and like someone said, they love the color scheme. I love the color scheme as well. This magenta with the black is really impressing me right now. So yeah, I'm kind of happy I went with this color. So anyways, without no further ado, let's get started with part 5 of the build. So I kind of did kind of mess up, but not really. So these holes that came with this plate, especially the outer holes, not the inner one. The 4 inner holes are cut precisely for the M3 8mm to mount onto the MG&H 15 carriage. Those are perfectly fine. But I noticed I couldn't push a M3 through this, and that's because this was supposed to be threaded. Okay, this was supposed to be threaded, so you can screw the bed directly, screw the bed with a standoff directly into this. Now I did kind of, before I even thought about that, I did make the hole bigger, the same size of this. So this screw, so the M3 screws are not sliding through this, which is fine. I have a solution by using these knuckle nuts in order to hold that in place. So no big deal there. However, I did tap these 2 screws, and that's to hold this in place, that holds the drag train for the drag chain that holds the heated bed wires. So that's what this for. So I tapped that, and then I made this hole bigger. I'm assuming you're supposed to tap it M5 holes. I made it bigger because this setup already has 2 square nuts inside. I'm not sure if you guys can see that. There's 2 square nuts in there. Let me see if I can kind of show that off. See those shiny bits in there? That's the square nuts already installed. So I have square nuts to hold it in place. So it's no big deal. But yeah, and then these 4 heated inserts are to just for structural integrity again, like just to keep this stiff, because this is where the load of the tension of the belt is going to be. So so it makes sense to keep this, put some M3 screws in it for rigidity. So without that, we're just gonna get started. So let's put this on first. Oops, something fell. This is the cover for this. So we're gonna go ahead and put this on. Trying to remember how this sits. Sits like this, so that means, is that correct? Yeah, it sits like this. Sits exactly like this. So go ahead and screw this in. Now, if you hear any printer movement in the background, I am printing off a ET mug for my wife in gold. She's gonna paint it. So you might hear my VZ butt zipping back and forth there. Like I said, I love that machine. And thanks for those who subscribe to my channel and never stop until I built one. And now I actually love it. I actually really love that machine. I love all my machines, but that VZ butt is really showing its impressive speed. Now, like I said, I could always print faster with it, but I'm probably not. The 12K acceleration with 200mm/second with PLA is plenty enough. Like, I don't need to go overboard. You know, I could always in the future, the benefit while having it this way is if I really needed an upgrade, like let's say I really needed to go AY with speed, I can always go get the aluminum, the carbon fiber, the X profile, or I can actually cut the aluminum beam in half, like, so basically cut down the middle and have two pieces hanging off and then mount the rails on that. So just leave the rails only. I've seen people done that and it seemed to work. So if I really wanted to save some weight, I could definitely do it that way. But the MGM9 is kind of thin, so I doubt I would do it that way, just because of the fact that it probably flex. But I'll just go carbon fiber or aluminum or lighter aluminum X-axis mount, and then go aluminum on the rest of the mounts, and that will lighten up and give it some speed. And then even go with a VZ about printhead. But for now, again, plenty enough speed. I can even go faster, but it's good enough for now. Anyway, so this is all mounted. So, alright, so now we're going to mount it on top of the carriage here. Trying to get this done pretty quickly and get it up and running. I want to see what it can do, because I'm planning to make this thing print pretty quickly, but also retain some print quality while we're at it. There we go. Just moving it back and forth to make sure it doesn't bind, because sometimes, since this is a thicker carriage and a thicker rail, it might not bind. But I know that MGM 12H and MGM 9H tend to bind if you tighten this down too much. They tend to bind up, but I'm not sure if because this carriage is so big and thick, it doesn't bind, so it doesn't even affect it. So, which is awesome. Alright, so that's mounted on there. Next thing we're going to do is go ahead and run our screws through here. Like I said, it's for rigidity. And if you guys might wonder why I have my headset on, I can kind of hear myself. I have a Blue Yeti, and apparently in the first video I had it too far away from me and didn't have the correct settings. So the first video I made, if you hear me kind of low, that's because it was kind of far away. It was actually behind my monitor, and I didn't have the correct settings. So now it's much closer to me, and I have the settings where you have to speak directly to the mic. It only picks up in the front and nowhere else. So that should drown out some of that background sound a little bit, and you should hear me much clearly. So, yep, so I have a Blue Yeti. Really nice mic. So I have my headset plugged into it, and I can actually hear how well I'm coming through, if you're curious why I have my headset on me. Almost there. Yep. Hopefully I'm not over threading with that. Sounds weird. Squeaky. but that's okay. We got it in. All right. Now we're gonna run the belt. So the belt sits in this little recess, as you can see. A groove there. So we're gonna fold it this way, I think. Yep, that's the way it goes in. Oh, slipped a little bit. Let's put some more here. Yep, got it. So as you can see, belt is in there nicely. All right. So now we're gonna put this cover on top of here. I'm going to over tighten it. Really like the clever design here, like just like a belt cover like that. Like you wouldn't even thought about it, but this is very clever design, man. Very clever. Alright, and there's a belt cover. Alright, so now we gotta mount it on here, like so. These are using M512 to mount it. And I already had the square nuts, like I pointed out early, in there, so it'll hold it in place. Okay. All right. So now we're going to run our belt that way, like so. Okay, I don't really see an issue. I might have to move out my thing just a little bit here to line up the belt. Let me see something. Just want to check to make sure I'm doing the right thing here. Okay, I'm correct. Just making sure. Alright, so we're going to run our belt. We're going to put it in here. So there's a little groove for the belt, a little slot. See that? That's where you put the belt in. So go ahead and slot that in here. There we go, nice and easy. Slid right in place, super, super easy. Very nice. I printed this on my V1 1.8, so the tolerance is actually pretty spot on, actually. Alright, let me go ahead and put the screw in there. This is to give it some tension. It's a M535, I think. It seems I might have actually. Seems I might have to take the side piece off first. Yeah, look like I might have to do that first, guy. Or actually, you know what? I don't have to. I can actually slide it in there real quick. Yep, I was able to slide it in. Yep, that worked. And I'm gonna screw it down. Okay. Trying to get this to screw down. It's taking this good old time, but it looks like it's not screwing in. So. Okay. Might be running into a little issue here. Might be running into a little bit of an issue here, guys. I think I need a slightly longer screw here. Yeah, I'm gonna have to go for a slightly longer screw. Ugh. trying to take this out, guys. It's kind of stuck up in there. Go for a slightly longer M4. That's what it uses. Yeah, this is better. I won't even use the washer. Just want to make sure it reaches. Oh, that border reaches. Okay. So let's put the washer in. Some reason it's not grabbing the actual thing. Like it's almost like that printed part is in the way. That's covering the belt. It's kind of weird. Yeah, something's going on. I can't really. So the struggle is I'm trying to line this up with the hole and it gets in there, but it's not grabbing the M4 nut at the end of this. There's a, see that M4 nut? It's not going in it. And even though this is much longer, it's behaving as if it doesn't want to go in there. Very weird. I think this belt cover might be the issue here, but I don't have any smaller M4 with a flat head, so I might run into a little bit of a problem here. So the only thing left to do is remove this thing, but I like it there. Yeah, this is very weird. Like you can tell it's supposed to be there, but it just wasn't, it won't go in. Unless I take this printed part off. But if I do that, then I won't be able to put... Oh, I got it. I was supposed to use a flathead M4. Let me see if I can find that, guys. I'll be right back. I'm supposed to use that. I think it says socket head M4. But let me see if I can find that. I'll be right back, guys. Alright, guys. So, I found one. I managed to find one. Thank goodness I didn't throw it away at the time. But I found a Philip head M4 screw, which is the correct length long, actually 35 millimeters, shockingly. And so it's not the best solution. I prefer one of the Allen wrench type, but it's gonna work in this case. So let's go ahead, push back our belt in there. Make sure we're doing this the right way, and that should help us avoid this problem. Now let's see, because now it has clearance from that printed part. Has it grabbed it? Trying to see why it's not grabbing like it's supposed to. Okay. You know what? Let me see, make sure clear this and see if there's anything in here. Oh, makes sense. Silly. Yeah, there's some piece of debris in there. This whole time I've been fighting and not realizing there's a debris stopping me from getting in it. So that could have been the problem too. But no big deal. See if we can clear the debris here. Because when I inserted the M4 heat insert, I didn't clear off the melted part on the inside, so that's probably it. That's what's stopping me. You guys can see that whole melted part here. Kind of gonna show you guys what it looked like. Oh, it fell. You guys can see that little melted. Yep. So that's what was stopping me from getting in there. So now we're gonna screw this back out. We'll try one more time. So I'm like, why is it not going in? And it's like a clear shot. I can actually see it. But I would explain why it wasn't able to get in. Right? So there's a clear path now. Let's try this again. Okay, let's try screwing it in. Look like it's grabbed. Not sure. Yep, look like it grabbed it now. So let's keep moving. Yep, it grabbed it now. So we just gotta just pull it in. There we go, it's going in. And create some tension. There we go. Whew. Yep, just a little piece of the melted plastic was preventing. There we go. Now we got a little bit of tension here. Trying to see how much tension I want. Don't want to go too tight. There we go. Yep. Yep, that looks good. That feels good. All right. Belt ran, as you can see. There we go. Feels good too. Very nice and smooth. No weird undulation in it. So, yeah, that looks really, really good. Plenty enough tension. Don't need to go overboard with it. Look, as you guys can see, plenty enough tension. All right, happy with that. All right, so let's see what's next. We are going to so that's done. So we just did this, all that we just done, ran the belt exactly like we did. So usually now it's just mounting drag chains and wiring. Now I'm actually going to save that a little bit of that in the background. I don't like doing wiring on screen because it's how should I put it, it's a bit of a challenge. But the benefit with this is it's a video, so I can edit it. So just like magic, for me it's gonna be maybe a couple of days, couple of hours in wiring and setting up. For you guys, it's like less than a second, right? So let me get all the wiring going, the drag chain mounted. Basically, I'm gonna do all of that. Basically the nitty gritty, because like again, the main part is done. The main part of the structural part is done. So the next clip is just everything kind of put together in a way. So just the drag chain ran, certain thing ran, just to save time. You know, because like I said, that would have extended this out too much, and so to save time, I'm going to get that done. So I'll see you in a second. Hey guys, and just like that, as you can see, we're all done with assembly. Now this has been a couple of days in the background from the last video. This video should have been out last week, but it's been a couple of days from that last of the clip you saw, and that's the magic of editing. You guys don't know what happened in the background, but yeah, it's been a couple of days. Well, about almost a week or so went by or so. But nonetheless, I got carried away and did everything, so I'll just kind of go over what all that I did to finish up. Now, in the last clip you saw that I didn't have the X belt ran or the gantry on, so now that's done. I ran the X belt, ran the drag chain, as you can see in the image there. Everything is nicely mounted. The cable I'm using, I took a IGUS cable chain. So let me see if I have a spare one to show. But I've showed you guys in my video. I don't have one on me right now. But I basically took one of the IGUS continuous flex cable and ripped the sheeting open, the enclosure open, and took the wires out of that to wire this up. So, you know, as you can see, all the black cabling looks really clean and nice. Use some not sure if you guys can see that there, but I used some heat shrink, different color heat shrink to kind of identify what each cable go to. I'm also using JST connectors. I personally will be sticking with JST connectors for pretty much all my future builds. Now I notice everybody's going to CAN bus. I know everybody's moving to that, Personally, while it's awesome that you can only use 4 wires to communicate with the boards, the downfall for me is the firmware update. I don't want to have to, when I do update Clipper, I have to update the CAN bus, all that stuff. That's a lot of just finagling with things. Maybe if it gets easier to firmware updates these devices in the distant future, then I'll move to CAN bus. But for right now, just wiring up, taking my time crimping cables and wiring up works perfect for me. Plus I find it as therapy, in my opinion, just sitting there kind of wiring up everything, make sure it's nicely put together. As you can see, I don't have no wiring issue with all my printers. That's one thing that I don't have issue from. Ever since I changed from the silicon cables to a continuous flex cable, not a problem at all. Like, whether it's high temp, low temp, it don't matter. They just work. A lot of people have confirmed the idea of using it, and like I said, I've been promoting this on my channel. That's all I use, and that's all I'll ever use. They're cheap. For a couple feet, the ones that I use is I might have to find a model, but if you look through my channel, you will see the model that I use, and I love it, man. Like I said, it's cheap. I get enough. It wires up my printer, and boom, it works every single time. No issues. It can take enough voltage to heat up everything, to control everything. I think they're 20 gauge wires, so they're pretty solid wires, able to carry enough voltage and everything for what we do. So yeah, but anyways, let's not go down that road. So that's what I use for the cabling. There's the squirrel brain, awesome design once again. I have to also shout out ratrig, because if it wasn't for the V minion, we wouldn't have the Tic Tac here, which I'm calling this one Magenta, and Magenta is a DC superhero, which is pretty cool. But due to the inspiration from the ratrig V minion, this is where this design comes, and I can tell you guys, I love this. I love this little printer. It's so neat, so rigid, just clever design overall, man. Like, I really love it. Now, it gained a good, I say this is a good 30 pounds in my hand. Like, and it's, like I said, it's solid. Solid, man. This is not going anywhere. I did some test print on it in the background. So as you can see, some example of the test print here. It's not bad at all, actually. It's not fully tuned and dialed in yet. In terms of config, it's tuned by config wise, but like in terms of my profile for this, I need to dial in some parameters on the profile. I do use Cura as my preferred slicer. Like I said on this channel, that's the only slicer I'm gonna probably use. I never will use Super Slicer, so don't mention it. I don't like the weight. I don't like Super Slicer for certain reasons. I don't like the user interface. It looks like Pruz Slicer, which I do use, and the reason why I have to use Pruz Slicer is because of my ERFC, right? It supports the multicolor printing stuff, and I had to force myself to learn it, even though I didn't like it, but I did. Super Slicer is like that multiplied. There's so much settings, there's so much stuff to go through. I don't really care about all of that, and you have to click through a bunch of stuff just to find what you need. In my opinion, Cura is just straightforward. I'm so used to it anyways. My profiles are pretty solid. I don't want to even mess with all of that. So this is not a slicer topic. This is back to the printer thing. So, but I printed some stuff here. Like I said, this is the Cali Dragon. Came out really good. Thanks to the belted Z, the layers are fantastic. Really good layers on this thing. Like really clean prints on this thing. So as you can see, it's nice and complete. It has a little case. That's the underneath. Little housing. So what's in this housing is a SKR Pico, like I mentioned, and a Pi 02. I managed to get a Pi 02 and paid $50 for this, man. This is $56 with shipping. Whew. Pretty expensive stuff, man. For a part that's supposed to really be $15, $50, man. It kind of stung, because I could have got 3 Pis for that price, but 3 Pi 2 for that price. But it is what it is. Now the reason I had to get a Pi 2 is because, like everybody said in the comments on my previous video, Pi 1 sucks. Like, other than basic printing, it really sucks. As soon as you add pressure advance or try the input shaper, none of that stuff work. It just cannot manage. I can sit there and look at mainsail and watch the core while it's printing, and as soon as it's starting to print fast, it just the CPU maxes out and boom, it just crash and give you the MCU timer too close error. So I decided to get the Pi 2, and that worked. That took input shaper perfectly fine. It's working perfectly fine. Now I'm still getting some crashing issue whenever the acceleration is above 15K. For some reason, it's still going into a timer issue, timer too close issue with the MCU, it says. But I found out it was Joyride infill. When I use Joyride, it will crash, but when I use any other infill, it works fine. It's kind of strange. I'm not sure what's going on there, but other than that, the Pi 2 02 is great. Works great. So that's what's stuffed in here with the Pico, on top of the Pico, and then I have a DC step up converter or step down converter from 24 volts. Yeah, so a step down converter. So I have this 12 volt 5015 fan that I overvolted to 14.5 volts to push a little bit more air, because the plan was to print a little faster with this. So right now, I'm gonna show you my settings for this right now in Cura, so I can show you at the speed I'm currently printing at. I'm still trying to tune things a little bit, but it prints pretty quickly for a little printer like this. It doesn't shake or jerk. It's pretty solid. While that's booting up, I had to double up the feet on here. Cura is in my way, so I can't see what's going on here. So I had to double up the feet on here. As you can see, the feet are extended because these original feet are too short. So I had to put those V wheels as a extension on the feet. As you can see it on all 4 feet. So that helped to ice it up, because the problem is the connector, the XT60 connector is at the bottom here, and so it was crushing the cable a little bit. So I had to like raise it up so that way it has some height so it doesn't crush the cable, right? So spec wise, I'm using the Sharper Mini here with a 24 volt high speed 4010 fan. You don't really need it like this because it's in open air, but you know, I like high speed fan. It just keeps things from clogging or anything like that. I'm using a standard flow Dragon and a like a third party BL Touch. It works perfectly fine for this means. And yeah, so it is nice. Like I said, it's cable managed really nicely. Try to clean it up, and thanks to my cable management skill, I was able to stuff everything in this housing. As you can see, it's nicely cleanly done. In the background, I had to reprint the Z motor holder. It was warped a little bit, and that's what was causing this to be tight in my previous videos. So now look, I can easily move it up and easily move it down. So that's what was causing the issue. So after I reprinted it, everything worked perfectly fine. So yeah, this USB cable here that you're seeing underneath, if I can find it. So this little USB cable is it's attached to the Pi 2. So that way when I want to run input shaper, all I got to do is plug this into the Pico. So I have the Pico wired up here. Let me see if I can grab it. Oops. So as you can see, got the Pico wired up. So all I got to do is when I want to run input shaper, I just plug it in with that there, that USB connector underneath the bottom. You see here. Make sure you guys can see that. So that's the cable. So all I got to do is just plug it in right there in the cable, and then just, you know, I use some Gorilla tape because it's very strong. This holds up to about 20 pounds, I think. So it holds it down really, really well. So I can do my input shaper, and that's it. So, but yeah, that's the purpose of that cable underneath. So all I got to do is just push it under. It can just sit there. It's not a big deal. It's not ironing or hurting anything by sitting underneath there. So that's what happened in the background. So yeah, guys, it's done. It's working good. I had to quickly print something to manage the PTFE here. So all I got to do is put my spool in on the side here, pulls it up, pulls it in, and it works perfectly that way. I could have I think you could mount the spool in front here, but you want a smaller spool, because if you're using bigger spool, it's going to interfere with the bed, because there's not much distance between the bed here and that frame, so it's not a big deal to me. But yeah, guys, it's all done and it's working great. So like I said, I really love this. I did enjoy this build big time. Absolutely love it, man. This thing's gonna stay on my desk and print a bunch of, like, you know, little busts, little prints that I like. You can even do big prints on this. I mean, not super big, but you know, to take up the whole bed, depends on what you're printing. But yeah, I can see this also being in a little small chamber if you wanted to print ABS. So you could just kind of put this in a little bit of a chamber here, a little box chamber, and this will definitely print ABS. The only problem you run into is you know, there's a little fan here for cooling off the MCU and the Pi Zero, just to keep everything cooled. I have them set and configured to not turn on unless the extruder is hot or the bed is turning on, then it kicks on. Just to make sure, you know, we save the fan, so that way they don't spin out and die. But yeah, guys, this is it. It's done. It is really, really, really nice. I'm really happy with it, guys. I am really, really happy with this. It turned out really nice. As you can see, everything is nice and smooth. The bed travels nice and smooth, so it's just nice. The MGM 15H rail does make a difference in terms of rigidity, and again, just the overall design made this a very robust, very quick little printer with belted Z. Just really, really nice. So overall, great job, Squirrel Brain. Man, I can't just thank you enough for making such a small printer. Really cool design. So yeah, guys, so that's what I did in the background. So just to keep you guys up. Now I can go ahead and do a print. So what I'm gonna do is I'm just gonna go ahead, start up a print, just, you know, plug it in, run up a print, get it preheated and everything, and then start a print so you guys can see it in action, and everything. So I'll be right back. Let me get that going, and just to save time, and yeah, so I'll be right back, guys. Alright, guys, now I'm back. Got it plugged in. Like I said, I'm just using a external power supply with XT connector. I want to say female. I think the male connector is on here, so it's a female connector plugged in. So it's all powered up. Let you guys see my. Let me get to the capture screen. Let you guys see it. So that's it here on the screen. As you can see, the temperature of my Pi is pretty down, and also the MCU, because I have the little fan. Let me see if I can kind of show you guys at the back here real quick. Rotate it without causing and making anything shut down. So you see that little fan there? Yep. So that's what's cooling off all of the electronics at the back here. Very convenient. It is 24 volt, some blue light at the back, and then I also have like I said, 4010 24 volt fan cooling off the hot end here. So I have sensorless ohming configured on this. It's just easier. I didn't want to have to run extra wires to it. It just makes it convenient, to be honest with you. Sensorless ohming does work really well, and it is accurate. The only problem is you just have to make sure how to configure it and set it up correctly. So for example, I don't want to go into a spiel, but with sensorless ohming, because I have sensorless ohming on my V1.8, both my V1.8, because of the new Stealth Burner update, it doesn't allow for a X end stop unless you're doing the 2.4 and tried it. But since I'm doing the 1.8, and the 1.8 doesn't really officially is supported by the Stealth Burner and Clockwork 2. So I'm going to a whole spiel, but I want to explain myself because it's just on my mind. But the older 1.8 add the end stop switch on the actual carriage itself. So, but when I updated it to the Clockwork 2 and Stealth Burner, it no longer has that built in. So you have to use sensorless ohming on the X. and it's pretty accurate. So back to the point of sensorless homing, as long as you have it set up correctly, even if you pause it and resume a print, it will come right back in the same direction. Just as long as you know when you pause it, you don't let it hit the actual basically you don't let it hit the gantry. Just take a make it pause a millimeter or two away from the actual stop location it will initially hit, you know, to stop it. Make sure it doesn't get close to that, so that way when you resume, it's not hitting on anything and it goes right back. So it's just how you configure sensorless homing to make it accurate, but it is accurate in my experience of using it so far. No issues with it. So yeah, so let's do a homing here since I have everything preheated for a while now. We're gonna do a home all so you guys can see it. Since the Z is also using the same 82 to 16 tooth ratio, I just copied everything from the 2.4 and configured it with the correct rotation distance and stuff, so it's working perfectly fine. My Z is pretty quick because I increased the feed rate on it in the config, so it's pretty fast. Yeah, but let's start a print. I have a print here that I pre-sliced that I wanted to kind of use up the PLA on, but of course the print won't complete here, but I just kind of wanted you to see the speed that I'm dealing with here. There we go. So as you can see on the config, you can see 12K acceleration, 600 millimeter velocity, and 8 millimeters for the square corner velocity. So again, it's pretty quick, pretty zippy, not the fastest. I haven't have enough time to really tweak around and mess with it, but I'm pretty sure I can push it a bit further too. But like I said, this is not like a super fast speedy machine, because like I said, it's not anchored down or anything, so we don't want it to go so fast that it's literally shaking itself to death now. But for the speed that it's displaying, it's pretty quick, and it's good enough to print my bus with with good results, and print pretty much anything I throw at it with good results. So that's the idea. So this is gonna sit right there in the corner of my desk. I have a very widescreen monitor, so it's not going to disturb my view at all, and I can just send a print job to it in the corner and just let it print. But yeah, I love this machine. Like I said, I cannot brag enough on Squirrel Brain coming up with such a good design. Like I said, I didn't mind building a V0, but I have so much Vorons, I didn't want to build another Voron, and this thing takes the cake for me. Such the form factor, how small it is, you can just pick it up. I can literally take this thing anywhere with me. For example, the Positron is a cool printer, in my opinion, really cool, but I don't want a Positron. Like, that looks complex to me. It just looks, I know he's going for the compact, fold up anything, but this thing you can pick up. It's so tiny. Like, I can literally pick this up, put it in my car, bring it anywhere, and still print on it. You know what I'm saying? Like, I don't need a positron for this. This is rigid, still can print fast, actually faster than a positron, and deliver really good results with belted Z. So in my opinion, this little thing is it. Power supply, boom, that's it. I don't really need a screen for it, honestly, because again, we have a Pi built in. If I can get on someone's network, boom, I'm there, so I love it, man. I really love this. So to the point where I'm gonna build another one as a gift for a friend, and I think she deserves it. She has been really good to me over the years, and so I think this will be fun. She wanted a 3D printer, something small, and this is right up the alley for her. So I'm gonna build this for her and surprise her with this. This is an awesome printer. Like, again, to me, this is an awesome printer to gift someone. Like, super small, perfect enough to print little items. A solid printer that can print pretty quickly. My overall opinion of this is a solid small printer. Definitely a miniature V Minion, but just to me, just much neater, so yeah, so there goes. Just laying down some filament now. I've already did the Z offset calibration and stuff, so it doesn't really need it. Let me see what this bed look like. Yeek. The bed is still kind of crazy. As you can see, they got some fixing to do here. The bed is a little on the crazy side, but nothing that I can't adjust and fix. What I'm gonna end up doing, since the bed looks like this, I'm gonna end up and it's a small bed, so it's not really affecting anything, to be honest with you, because as you can see, it's really just laying down filament across the whole bed, no issues. It's just that one side is more squished than one, so you can see where it's affecting it. What I may do is I'm actually might move these solid little metal mounts here, the standoffs, and put actually some cut some springs, so that way I can actually do some minor adjustment with some springs. So 3-point leveling with it, and I think that will kind of help the whole straighten out the bed. But like I said, outside of that, guys, it's an awesome printer. It's laying down the first layer. It's looking incredible. But yeah, this is it, guys. I don't want this to be too long. Maybe I'll just do a little small quick video to show you the result of this, or maybe like another quick video that I usually post, a little 15-second video to show you the speed while it's getting on it. But yeah, guys, this is it. This is the build. It's completed. And I love it. I love it. Yeah, anytime I build printers, it'll be this for sure. If I'm building it for someone, it'll be something like this. But yeah, guys, but anyways, I hope you enjoyed the build process. I did enjoy it. I hope you did enjoy it. I hope some of you guys build this. I think it's an awesome little printer. But like I said, support to the designer, Squirrel Brain, awesome design, man. Not much to criticize it about. It's great. I don't have an issue to criticize. You know, any little thing that we worked out was in the background. Like I said, a couple things that, you know, like this broke off initially because of the way I printed it, and he re-strengthened this. A couple other things was retweaked and redone to make it better. But outside of that, it is phenomenal. I really love it. And so yeah, guys, hope you enjoy part 5. Again, shout out to Squirrel Brain, shout out to Ratrig, who inspired him because of the V Minion, and to make something like this. And again, yeah, shout out to the awesome printing community, and shout out to my supporters, you know, guys, you know, subscribers. Almost at 2K subscribers. So if you guys don't mind, just hit that like button, you know, tell a friend, share the video with a friend. Yeah, and look out for more videos. So stay tuned, guys, and I'll see you in the next one. Peace. Alright, guys, thought I was gone, but I wanted to show you the speed. So as you can see, let's show you the TikTok so you can see what it's doing. So if you want to look at the status there, you can see in the corner that it's pretty quick. It's and I forgot to even mention, I did some prints as well. What I love about this as well, forgot to show, is it's good quality. The Z actually helped. The belted Z really helped in this case, giving you very consistent layer. Notice that. Look at the top. Top is really clean. Yeah, it's a nice clean cube that I printed pretty quickly. So again, guys, the quality is phenomenal. Try to put there. Quality is phenomenal, guys. Keep in mind I have the light shining down, so you might see some inconsistent layer extrusion. Not per se, but like, you know, when you hold any type of 3D print in a light like that, harsh light, it's not gonna look the greatest, but actually it's not too bad. So yeah, so it's producing quality print, guys. As you can see, the infill is pretty fast. It's actually moving pretty quickly around the parameters. As you can see, it does hit 200 millimeters a second in the infill. Let me show you my, see if I can pull up my print settings so you guys can see what I'm printing at. But yeah, I just want you guys to see that it's actually zippy. It's not slow at all. It's pretty zippy, guys. Now, in the Clipper world, you don't necessarily have to use the slicer to control your speed, but I do. I like to decide where the acceleration needs to be. But here's my acceleration and speed for this little printer. So let me change the window here. Can I change it to Ultimate Akira? So if you can see, guys, here in this little window, let me try to see if I can do a scene capture here. So as you guys can see, that is my speed for this little printer. 150 millimeter second print speed all around, 100 out of wall, 200 millimeter in infill speed, 600 travel, 10K acceleration, except for the outer wall here. I lowered it, but just a little bit to not to get any ringing or anything like that. But as you can see, guys, it's zippy. So that's the speed I print at, and it reflects on the actual print status that it's really hitting those speeds. And it's looking real good, guys. Looking absolutely excellent. So yeah, guys, as you can see, very small, quick printer. Yep. I'm very, very and thoroughly excited about it. But anyways, that's it, guys.